So this video is on the chapter 4.5 to 4.8 test review. It's the Pear deck one. So on this first problem, we are going to be finding the pieces and then doing the graphs. This is a cosine graph. The amplitude is a number in front of our cosine, so that's 2. My period is going to be 2 pi divided by b, so this is going to be 2 pi over 4, so that's going to be pi halves. My phase shift is what's going to make this equal to 0, so I'm going to set this equal to 0. 4x minus 2 pi thirds equals 0. So I get 4x equals 2 pi thirds. I'm going to divide both sides by 4. Or another way of thinking about it is I can multiply by 1/4, and that's going to have the 4's cancel out, and I end up with x is equal to 2 pi 12ths or pi 6. So my phase shift is pi 6. And then my vertical shift is at 3. So in terms of my graph, I am going to be going up to 3. I'm going to be going 2 above that, which is going to be 5. I'm going to go 2 below that, which is going to be 1. And this is where my zeros would be. Okay. We are starting at pi 6, and I am going pi halves away, and so I'm going to rewrite pi halves as 3 pi 6. So I'm going to end at 4 pi 6 or 2 pi thirds. So I'm going to have at pi 6, 1, 2, 3, 4, 5, and that's 4 pi 6 or 2 pi thirds. And then when I'm graphing this, my cosine starts at high to high. It's positive, so I'm going to go here. Pi 6 is going to be up at 5. At 2 pi thirds, it's going to be at 5. Halfway in between, it's going to be at 1, and halfway between those are where it's going to be at 0. And then I can graph my cosine graph. Okay. Next one. So number 2, this is going to be a sine. My amplitude is 3. My period is going to be 2 pi over my b, which is 2, so it's going to be pi. My phase shift, I'm going to take this, 2x plus pi fourths is equal to 0. So I'm going to have 2x is equal to negative pi fourths, which is going to be x is equal to, and when I divide by 2 or multiply by 1/2, I get a negative pi 8. So I'm going to start at a negative pi 8. And my vertical shift is -1. So when I'm trying to figure out where I'm starting and ending, I'm going to start at negative pi 8. I'm going to be adding pi onto that, which is 8 pi 8. So I'm going to end up at 7 pi 8. So when I'm starting on the negative side of the x-axis and ending on the positive side of the x-axis, I'm not going to just mark my 5 marks, because sometimes the y-axis is not going to be one of those, and a lot of times people think it is. So what I'm going to do is I'm going to actually go by 8s. So this is going to be a negative pi 8. So that's negative pi 8. This would be a positive pi 8. So 1, 2, 3, 4, 5, 6, 7. That's 7 pi 8. My vertical shift is a -1. So let's see if I can move this a little bit. So I am going to be, I'll extend this slightly. I'm going to come down here to, let's say, -1. My amplitude is 3, so I'm going to go down to -4. And I'm going to go 3 above that, which is going to put me up at 2. And again, these would be my zeros. Scoot it over a little bit. So now, when I'm doing this, my sign starts at 0, ends at 0. So I'm going to start here at my -1. This is my -1. And then halfway in between these, now I've got 1, 2, 3, 4, 5, 6, 7, 8 eighths here. So halfway would be 4 of them. So 1, 2, 3, 4. That is going to be my halfway, which is another 0. And then halfway between 1, 2, 3, 4 is going to be 2 and 2. So that's 1, 2. Okay. And since this is a positive sign, it's going to be up here at 2. And then again, I'm going to go 1, 2. Okay. And that's going to be my -4. And this is going to be my sine graph. And you'll notice that, you'll notice that the, get rid of that. Try again. Okay. Let me get my point back here. Okay. And you'll notice that my y-axis was not one of these 1, 2, 3, 4, 5 points I graphed. So if you are starting on the negative side of the x-axis, going to the positive, you want to be careful. If I'm going by eighths here, because this is eighths, then I will scale by eighths. And then I will just do my start at 0, end at 0, and then halfway in between those, 0, and then halfway between those, and halfway between those. Okay. Next one, this is a secant. So a secant, reciprocal wise, S doesn't go with S, C doesn't go with C. So when I am doing my secant, the reciprocal of this is going to be a cosine. Okay. And so if I'm graphing my cosine, I'm going up to 3. Let me drop that down. Get a bigger eraser. Okay. So when I'm drawing this, okay, I need to go up to 3, so I'm going to drop it down here. So I need to go up to 3, and then I'm going to be going 1 above, which is 4, and 1 below, which is 2. And this is where my zeros are going to be here, okay? And so anywhere my cosine graph touches that, that's where I'm going to have asymptotes for my secant. Now this cosine is going to not have a phase shift, so I'm going to start at 0. I do have a 2 in front of my x, so that means 2 pi over 2 is going to be pi. So 1, 2, 3, 4, 5 pi. And let me graph my cosine. So cosine, I start at my high normally, but because of that negative, I'm going to start at my low. So I'm going to go low to low. Oops, forgot. This is actually at my 0. Low to low. Halfway in between is going to be my high, and halfway in between that is going to be my 0. And so that, let me make that skinnier. So halfway in between, again, my high and my low is my 0. So I've got 0 here and 0 here. So I'm going to have asymptotes there. Now, what's going to happen is, and let me just kind of scale this just so everyone understands, that's pi 4 pi. That means that this is pi halves. And so since I have 4 marks getting to pi, these are actually pi fourths. So this would be pi fourths. Pi halves is 2 pi fourths. This is 3 pi fourths. So I either need to go a fourth on this side, which would be 5 pi fourths, or a fourth on this side, which would be a negative pi force, to continue my cosine graph and get to my other 0. Or on this side, get to my other 0. So I usually go in front, but I know some of us are going behind, which is not wrong. So this is going to be at a negative pi force. This is going to be at pi force. This is going to be at 3 pi force. And again, some of us went to the other side and had one at 5 pi force. So now my secant, sorry, I'm going to have this point that it shares and it goes down. So that is part of my secant. And it shares that point right here at the top. The orange is my secant. Tangent. Okay, so for tangent, when I'm doing this type of a situation, I'm thinking about my unit circle. I'm thinking about tangent is sine over cosine or y over x. So wherever my x is 0, wherever this is 0, that's where I'm going to have an asymptote. So my x is 0 here and here. So I'm going to have an asymptote at pi halves. Let me make that skinnier. So I'm going to have an asymptote at pi halves and negative pi halves. That's where my asymptotes are going to go. And as I'm going from negative pi halves, which is asymptote, all the way to pi halves, along there, I'm going to be graphing a -1, a 0, I don't know why it's not happening, sorry, and a 1. Okay, so the next thing I'm going to do is this has been shifted. So I'm going to take the basically the b times x minus h part of this, which is in this case, this 2 pi x, and I'm going to set it equal to my asymptotes, which is negative pi halves and positive pi halves. Okay. So when I'm doing this, I probably would think of this as timesing by the reciprocal, timesing by the reciprocal. So up here, I'm going to get x is equal to, because my 2 pi and 2 pi are going to cancel out. Here, my pi and pi are going to cancel out, and I'm going to get a negative 1/4. Now, when I do this one, I'm going to be doing the same thing, but this time it's going to be a positive. So it's going to be a positive 1/4 when I do that math. So those are my asymptotes. So I am going to be always 5 marks. So 1, 2, 1, 2. So this is going to be -1/4. This is going to be positive 1/4. There's no vertical shift or amplitude change. So that's going to be a 1 and a -1. So I'm going to have an asymptote here at x equal -1/4, an asymptote here at x equal 1/4. And then what I'm going to do is I am going to be thinking about how I am going around the unit circle. And so let me do it in green. So again, if I'm looking at the unit circle, I'm starting here, asymptote, let me make it a little thicker. Asymptote, -1, 0, 1, asymptote. So asymptote, -1, 0, 1, asymptote. And there's my tan. Okay, cosecant. So a cosecant is going to be a sine for the reciprocal. So let me graph my sine for this. I'm going to be starting down at -1. That's where my zeros are going to be. This is where my zeros are going to be. Okay. And I'm going to be going 3 below that. So I'm going to be going down to -4. and 3 above that, which is going to be positive 2. Now, I don't have a phase shift, so I'm going to start at 0, and I'm going to go 2 pi divided by b. My b is 2, so it's pi. So I'm going to go 1, 2, 3, 4, 5, and that's pi. Okay, so in terms of a sine graph, 0, 0, start and end, halfway is a 0. I'm going to go up to a 2, down to a -4, and here is my sine graph. And so you see it crosses in 3 spots. It's a little thicker. It crosses, it's 0 here at x equals 0. It's 0 here at, start again, 0 here at pi halves, and it's 0 here at pi. And then I'm going to come to this point, and it's going to go up, and I'm going to come to this point, and it's going to go down. And there's my graph. Okay, so cotangent. So again, if you're thinking about the unit circle, we're thinking that this is cosine over sine, or x over y. So I want to know where my y is 0. And my y is 0 here at 0 and at pi. And as I move around the unit circle, going this direction, I'm going to go asymptote. So I'm going to put like zeros and slash, so asymptote, undefined, 1, 0, -1, undefined. That's what I'm going to be graphing. Now I am going to take my 2x minus pi halves, set it equal to 0. So that'd be 2x is equal to pi halves. So x is going to be equal to pi fourths. Then I'm going to take the 2x minus pi halves and set it equal to pi. So it's going to be 2x minus 2x equals 2x equals, and I'm going to add pi halves to both sides, which is going to give me 3 pi halves, and I'm going to divide by 2, so I get 3 pi fourths. So that's where my asymptotes are going to be. So I am going to be going up to 1, down to -1. I'm going to be starting at pi fourths, and I have 1, 2, 3, 4, 5, and that's going to end at 3 pi fourths. And I'm going to have an asymptote at pi fourths, x equal pi fourths, and x equal 3 pi fourths. And then again, as I'm going around my unit circle, I start, and I'm doing this in blue this time, undefined, 1, 0, -1, undefined. So I'm going to go undefined, 1, whoops, hold on, let me actually get it in the right spot. 1, 0, -1, and there's your cotan. So on this one, we want to figure out all the pieces. So I want to get my y by itself, everything else away from it. Myself personally, I am going to add this. Let me do it this way. Hold on. I'm going to add this to this side, and I'm going to add this to this side. So when I do that, I'm going to end up with y is equal, sorry, I'll do it in the order that I have it here. I'm going to have 2 plus sine 3 of theta minus pi 6 is equal to y. Again, I'm adding my sine 3 of theta minus pi 6 to both sides. I'm adding y, and I get this. So my amplitude is going to be 1. My period is going to be 2 pi divided by 3. My phase shift is going to be pi 6. and my vertical shift is 2. Okay, so on a problem like this, I'm going from 0 to 2 pi, but not including 2 pi. I want to know where my cosine is a negative root 3 over 2. And what you want to pay attention to is 1/2 versus a root 2 halves versus a root 3 halves. This is short. This is long. And then the root 2 over 2 is the one in the middle. It's always with your force. Okay, so if I want my cosine, which is my x, okay, so these are always cosine of your angle, comma, sine of your angle. So I want my cosine to be negative. I want a negative x. I want my x to be long, short. So it's going to be here, which is 5 pi 6. And down here, which is 7 pi 6. So my answers are that x is going to be 5 pi 6 and 7 pi 6. Those are your answers. So cosecant. So the reciprocal cosecant is sine. So I really want my sine to have been the reciprocal of root 2, which is 1 over root 2. And then I would rationalize. And when I rationalize that, I get root 2 over 2. So I want to know where my sine is root 2 over 2, a positive root 2 over 2. And again, remember it's cosine, comma, sine. So that is going to be here at pi force. And another positive sign would be over here, which is 3 pi force. So my answers are going to be pi force and 3 pi force. Okay, so tan inverse or arctan. I'm starting here, but open circle. Open circle, because that's going to be undefined. So I'm going negative pi halves, but not including that, because that would be undefined up to pi halves. And when you're thinking about your point, you're thinking you're going this direction and this direction. We're not going around the whole unit circle. We're going backwards, okay, to get to quadrant 4. So I want to know, where is my tan going to be a -1? So that's going to be down in quadrant 4 here. And that's going to be, remember, tan is sine. Hold on a second, I'll get this. Is sine over cosine, or y over x. So basically, I want my y and x to be the same coordinates, but I need them different signs. So I am going to end up having that right here. And that is negative pi force. And that's your answer, negative pi force. Okay, where my sine inverse? So sine inverse is going to be like our tan inverse. Get this a little bigger here. I'm going to be starting here to here to here. And I'm going to be going like this direction. So again, this is going to be a negative pi halves to pi halves, but I can include a negative pi halves and the pi halves. Now it is a negative root 2 over 2. For my sine, that's going to be here. That's going to be here, which is negative which is going to be negative pi force. So my answer is going to be negative pi force. That is my answer. Okay, so on this one, we need to start with this inside part, and I'm just going to use this. I'm not going to put it in a particular spot, but if I'm dealing with arc cosine, I'm starting at 0. I'm trying to get this a little thicker. I'm starting at 0 and I'm going all the way here. It's not wanting to do it. Okay, starting at 0 and I'm going all the way here to pi. Okay, so I'm going 0 to pi is where I am for that cosine inverse. And in this case, I'm going to be doing cosine of cosine inverse. Now that would be in quadrant 1. And I could draw it out and put my angle here, and it would be 2 here and 3 here. And I could use Pythagorean to find my missing piece. But in this case, I want cosine of cosine inverse. Cosine and cosine inverse undo each other. So as long as my cosine inverse is defined, and in this case, it is defined. This is defined. Okay, that is defined. When is it not defined? If your cosine is greater than 1 or less than -1. So my answer is going to be 2/3 because they undo each other. Okay, I didn't really have to draw it out, but you do need to pay attention to your 2/3 and make sure it's not greater than 1. Oops. Okay, so number 13. So similar idea, except for this one, they aren't undoing each other. So I'm going to have to do some math here. So sine inverse, I'm going from here. Right again. I'm going from here, a little better, to here. That's where I'm looking. And so I am going to be in this quadrant. I'm not drawing this to scale. Sine would be opposite over hypotenuse. So I can use Pythagorean. So 2 squared plus x squared equals 7 squared. So I get 4. Try it again. I get 4 plus x squared equals 49. So x squared is equal to 45. I'm going to take the square root of that. Now I can clean up the square root of 45 because that's a root 9 times a root 5. So I can write that as a 3 root 5. So now I want tangent of this. So tangent is going to be opposite, which is 2, over adjacent, which is 3 root 5. I need to rationalize it. So I need to multiply top and bottom by root 5. And my final answer is going to be 2 root 5. And then root 5 times root 5 is 5. So I end up with a 15 on bottom. That is the value of that. Okay, on this one, okay, I'm going to try to find sine inverse. And again, sine inverse is going to go from here to here. And I want where my sine is going to be a 1/2. So that means I want long short. I'm going to be right here, which is going to be at pi 6. So now I want secant of pi 6. Now the point at pi 6 is going to be long, which is root 3/2, comma short, which is 1/2. Secant has as its reciprocal cosine. My cosine of this angle would be root 3 over 2. So my secant is going to be 2 over root 3. And then we need to rationalize it. So we need to times the top and bottom by root 3. And when I do, I'm going to get 2 root 3 over 3. And that's my answer. Okay, on these ones, we're going to be talking about the domain and range, okay, of these, if we think about them as graphs. Okay, so for my sine, this is going to go from -infinity to infinity. but my range, my minimum should be -1 and my maximum should be 1. That would be the same for my cosine. My cosecant is the reciprocal of my sine. Now, remember, this is going to have asymptotes, okay? So if I just am going to do a sketch up here of a sine, where this is 0, this is pi, this is 2 pi. I have asymptotes at 0, at pi, at 2 pi for this. So this does go out forever and ever, but it's going to be all real numbers except plus or minus pi n, where n is an integer. Okay, n is an integer. Okay, that's where it's not going to be. My range is, remember, these are going to go here and go, trying to draw this in, it's going to go start here and go up, and then start here and go down. So it's not going to be from -1 to 1. It's outside of -1 to 1. So it's going to be from -infinity to -1 union 1 to infinity. So it's going to be basically everything outside of -1 to 1. Now, my tangent is going to be going forever and ever and ever, but I have some restrictions. So if I draw a unit circle, I'll draw a unit circle here. Okay, so if I draw, let's see if it'll let me draw. If I draw a unit circle, a little skinnier. So if I draw a unit circle, tangent is 0. Well, I shouldn't say 0. Tangent is undefined when y over x, when my x's are 0. And my x's are 0 here and here. So it's going to be at all my pi halves. So this is going to be all real numbers except plus or minus pi halves times, well, my odd ends. Okay, maybe I'll do it like plus or minus odd ends. Because evens would be making it become pi's. Okay, so this is odd integers, and this is just going to be any integer. Now, the range of this, these are the graphs that go up forever and down forever. So this is going to be -infinity, -infinity to infinity. Now, my cotangents are going to be the same, except their asymptotes are going to be at plus and minus pi n, where n is an odd, is an integer. And then this is going to go from -infinity to +infinity. all of your inverses here. So when we're doing these, I'm just going to draw it here for myself to see. And no, doesn't want to skipping. Just think about where I am on these. Okay. So remember, for a cosine inverse, we're going from here to here. For a sine inverse, we're going from here to here. For a tan inverse, again, open circle, here to here. Okay, now remember, these are the inverses of our sine and our cosine. And so that means our x and y's get switched. So my cosine graph generally, well, our cosine graph, my cosine x's are negative infinity to infinity. So that means that hold on a second, would have been my, let me get this. Okay. So what would have happened is I normally would be doing that, but we have it restricted. We're not going forever and ever out in around the unit circle. We're going from 0 to pi. So this is going to be 0 to pi. And then this is -1 to 1. My sine inverse is also -1 to 1. And this is not going to go from 0 to pi this time. This is going to go from -pi/2 to pi/2. That's what I shaded in my unit circle. And then my tan inverse over here, I'm going to go open bracket -pi/2 to pi/2. And then this is going to go -infinity to infinity. Okay, write one sine and one cosine for this. So when we're looking at this, I like to look at my high. And so my high is at 3. My low is at -3. So that means my vertical shift is 0. So that means my K is 0, or I don't need to put that. Now my amplitude is the distance from here to here. And so that means my A is going to be 3. Now I think I'm going to start with my cosine graph first. And I think I'm going to start right here. And I'm going to go to here. And if you're looking at it, that is 3 pi distance. That is my period. So period is equal to 2 pi over b, and my period is 3 pi. So I'm going to get 2 pi is equal to 3 pi b, divide by 3 pi, and I get b is equal to 2/3. So my b is going to be 2/3. Okay. So now let me write my equation. So let me start with my cosine, and it's going to be a positive cosine with a positive 3. Cosine, my b is 2/3. I'm starting at 0, so x. And then it would be a +0, but I don't need to write the +0. Okay, so now if I'm doing it as a sine, I want to start at my 0, okay? Now, to find a nice 0, well, the zeros here are not going to be super nice. I'm looking at them. None of them look super nice. But what I can see is that Halfway from 0 to 3 pi, which would be 3 pi halves, okay, would be right here. So that would be at 3 pi halves. And then halfway between that and my 0 would be this. So again, this would be at 3 pi halves because it's half of 3 pi. And then I'm going to take half of 3 pi halves, which is going to be 3 pi fourths. So for my sine, I'm going to start here. And I am going to go, and I'll do it in this pink. I'm going to go like this to here. Let me maybe do it in yellow. This to here. And so it is going to be a negative sign, 2/3 still. I'm going to start at 3 pi fourths again. It's hard to see, but I know that halfway between 0 and 3 pi would be my low. And halfway between my low and my high would be my 0. So it has to be halfway between 3 pi halves and 0, which is 3 pi fourths. So this is going to be an x minus 3 pi fourths. And then plus 0, but I don't need that. Okay, so for this graph here, let's see, my high is going to be, let's see, it looks like negative 16. So that's negative 16. My low is going to be a negative 26. Halfway in between, I can average those. So that would be a negative 32. So it's going to be a negative 42, sorry, a negative 21. Again, I took my negative 16 plus my negative 26 divided by 2. I got a negative 42 divided by 2, which gave me my negative 21. Okay, so I know that this is going to be my K. My amplitude is going to be, or my A is going to be a 5. Let's see. So if I'm going to start with a sine, let's say I start here and I go starting here and I go, let me get my, okay, starting here and I go this direction. So that, if I look at my scale up here, I'm going by ones. So that is going to be at a negative 2. So for my sine, I'm going to have y, difficult, y is equal to positive 5 sine. And then for my b, let's look at a whole cycle. So if I start here and go like this, and so I'm starting here, ending here, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's 16 units for my period. Okay, I'm just counting from here to here is 16. So 2 pi over b equals 16. So 2 pi equals 16b. So 2 pi over 16 or pi eighths is going to be my b. So I'm going to have pi eighths I'm starting at 2, so x minus 2 minus 21. So that's going to be my sine. If I'm doing a cosine, I can start in different spots. Let's say I start here. If I start there, I've got 1, 2, 3, 4, 5, 6. So this is at 6 in terms of on my x direction. I'm going to be a positive 5 cosine, still the same pi 8s. I'm starting at 6, so this is going to be x minus 6 minus 21. Okay. And the last one. Okay, so on this one, sunset times vary sinusoidally with time. The longest day of the year occurs at about day 172. That's going to be the longest. Get some of these values. Okay. So it's going to be my longest is at day 172, and my shortest is going to be at day 355. For the town of Pear Sound on June 21st, the sunset time is, so December 30, or sorry, that was June. So that was going to be my long day. It was 21.18 hours. And then on December 21st, which is my short one, it's 16.68. They want to graph it and find the time of the sunset. Okay. So in this situation, let me get a regular pen. Okay. So I'm basically going to be going a low of 16.68. Let me space that out better. 16.68. And let's zoom in. So this is 16.68. My high is 21.18. So I'm going to average them. Okay, I'm going to add them up and divide by 2. So 21.18 plus 16.68 gives me 37.86. So 37.86 divided by 2. And that gives me 18.93. And so this is where my zeros are. These are my highs. These are my lows. Okay. And I know that, let's get it out of highlight. I know that we had a high at 172. So let's just say that this right here is 172. Hold on. Being difficult. Okay, so let's just say this is one. I'm not spacing it perfect. That was our high. Our low was at 355. I'm going to space this out a little bit more. Okay. So try it one more time. Okay, so let's say that this is, make it smaller. Okay, so let's say that this is my 172. doesn't want to write. So let's say that this is my 172. And then this is my 355. And this is my high. This is my low. Now the distance from here to here, 355 minus 172 is 183. So if I go another 183 to 355, I am going to be at 538, and that would have been another high. And then halfway between these would have been my 0 and my 0. And there's your graph. And we need to come up with an equation for this. So the distance from here to here, 21.18 minus 18.93 is 2.25. So my A is 2.25. My K is going to be this 18.93. This is where I'm going to start my cosine graph. Okay, so I'm going to write y is equal to a positive 2.25 times cosine. Now I need to find my b. Now my b, 183 plus 183, that's going to be my period. So 183 plus 183 is 366. So that means if I take 2 pi divided by b equals 366, and I work that out, I end up getting pi over 183 is my b. So this is going to be pi over 183 times x minus 172, and then plus my 18.93. So sorry, it's a little messy. Let me highlight it. Okay, oops. Supposed to be a highlight. That's really thick highlight. I will rewrite it over it. Okay. All right, one more time. So y equals 2.25 cosine of pi over 183 times x minus 172 plus 18.93. And then if they wanted us to figure out, so if they wanted us to figure out April 30th, I would have to figure out what day this is, okay? So let's see. So January, we have 31 days in January. So oops, I'm in text, sorry. So January, I put January, we have 31 days. February, we have 28 days. Let's assume it's 28 in this situation. And March is 31 days. And then we want the 30th day of April. So if I add that together, so 31 plus 28 plus 31 plus 30, I get 120. So I am going to put in 120 in place of x into my equation. So let me get this up on Desmos. Give me 1 sec to get that up. So I put it into Desmos, and in place of my X, and I made sure it's in radians by checking here to make sure it's in radians. In place of my X, I'm going to be putting in 120. And so it's going to be 20.34 hours. That's going to be our answer. 20.34. So for when is the sunset, find the sunset time, 20.34 hours. Okay, good luck tomorrow, guys.